welcome to this explainer. Look, if you've been online, reading the news, or just existing in an office lately, you've definitely been hit with an absolute avalanche of artificial intelligence jargon. LMMs, RAG, tokens. Honestly, it can feel like a completely different language. But today, we're going to change that. We are going to totally demystify this alphabet soup into a really easy to understand journey. By the time we wrap up, you won't just know the definitions, you'll understand exactly how they all actually fit together.
So let's just lay out our roadmap for today. We're tracking the whole life cycle of an AI model across 4 phases: the core of AI, teaching the machine, upgrading the brain, and finally, AI in action.
All right, kicking things off with phase 1, the core of AI.
Let's start with the big one, right? LLM, or large language model. You hear this everywhere. This is the actual brain powering the tools we're all using every single day: ChatGPT, Claude, Gemini, Copilot. Now, we know they've consumed billions of human documents, but what is actually happening underneath all that impressive output? It's not magic, guys. An LLM is simply predicting the most likely next word, but doing it on a massive, massive scale. It's basically the world's most incredibly powerful autocomplete, calculating probability word by word. But here's a fun fact. These models don't actually eat words the way you and I read them. They eat chunks of text, and we call those chunks tokens. Think of a token as the fundamental building block of AI communication. So if you take the word unbelievable, the AI doesn't see one word. It breaks it down into chunks: un plus believe plus able. Now, why should you care about this microscopic level? Well, because in the enterprise world, tokens are literal currency. The golden rule is that more tokens equals more cost. Tracking these tokens is exactly how you keep an eye on your AI budget. Now, what happens when the AI is trying to predict those next tokens, but those billions of training documents actually have gaps? Well, you get a hallucination. And yeah, this is where things get a bit sketchy. This is when the AI just makes stuff up, and it is confidently completely wrong. It will give you this beautifully written, highly articulate answer that is just 100% fiction. It's just trying its best to fill in missing gaps based on probabilities. But don't worry, we're going to see exactly how to fix that later on in our roadmap.
Which brings us perfectly to phase 2, teaching the machine. So there's this massive dividing line in an AI's life cycle, and it's training versus inference. Training is the teaching phase. This is the super expensive, grueling period where the AI actually learns the patterns of language from all that data. Then you have inference. That's when the AI actually gets a job and goes to work, taking your prompt and generating a response. The absolute key takeaway here: you cannot have the second without the first. Training is the prep work, inference is game day. Okay, but what's actually happening inside the hardware during that training phase? Under the hood, all of that learned intelligence is literally just stored as mathematical numbers, which are called weights. These weights literally shape what the model knows. They start off completely random, and as the AI digests info, it constantly dials these numbers in to get better at predicting text. It's wild to think about, but when you're talking to an AI, you are interacting with millions or billions of these perfectly tuned mathematical weights. The intelligence is just pure math.
And to grade that massive web of weights, developers use a metric called validation loss. Think of it as the AI's report card to see how well the training is actually going. For developers, a lower score is always better here. Keeping a close eye on this helps them catch something called overfitting before it's too late. Overfitting is basically when the AI just memorizes the textbook instead of actually learning how to think and generalize. So, keeping that validation loss low ensures the AI stays adaptable and actually useful. All right, moving right along to phase 3, upgrading the brain. So how do we make these models smarter? The first big upgrade trick is fine-tuning. If the initial training was like giving the AI a general high school education, fine-tuning is sending it to med school or law school. You take a general model, feed it highly specialized data, like complex legal contracts or medical journals, and boom, you get an AI that is incredibly smart at one specific thing. This is exactly how we build specialized enterprise tools tailored for exact industries.
Next up is an insanely powerful upgrade called reinforcement learning. Instead of just throwing more text at the AI, this is an interactive learning loop. It boils down to 3 simple steps: trial, reward, and repeat. The AI attempts a task, and if it nails it, it gets a mathematical reward. This constant, iterative loop of trial and reward is what makes reasoning models so much sharper. It literally rewards good logic.
Honestly, reinforcement learning is exactly like training a really good pup with treats.
Just like you ask a dog to sit and toss it a treat when it listens, developers give the neural network a positive mathematical signal when it gets an answer right. Through endless repetition and positive reinforcement, the AI learns the optimal behavior. It's just a digital golden retriever, learning the ropes.
Our last upgrade technique is all about efficiency, and it's called distillation. Look, massive models are brilliant, but they are incredibly slow and super expensive to run. Distillation is when you teach a small, cheap, mimic model to copy the behaviors of a massive teacher model. The payoff is huge. You get a model that's faster, way cheaper to run, and nearly as good as the giant original. This clever mimicking trick is almost certainly how we got lightning-fast models like GPT-4 Turbo.
And that brings us to our final phase, Phase 4, AI in action. Let's see this stuff in the real world. Okay, remember those super frustrating hallucinations we talked about earlier? The ones where the AI just confidently lies to you? Well, RAG, which stands for Retrieval Augmented Generation, is the fix, and it's brilliant. The formula is wonderfully simple. You take the AI and you pair it directly with your own trusted internal documents. Before it answers you, it's forced to go retrieve factual data from your files. Mixing the AI with your own specific documents dramatically reduces errors and keeps the whole thing grounded in reality.
Another amazing real-world technique is chain of thought. You know how sometimes an AI rushes to an answer and completely whiffs it? Chain of thought forces it to slow down. It breaks a complex problem into logical steps, moving from step 1 to step 2 to step 3. It essentially forces the AI to show its work, just like your middle school math teacher always yelled at you to do. Yes, it is a little bit slower, but it is remarkably more accurate for complex problem solving. And all of these concepts, everything we've talked about today, culminates in what we call a coding agent. This is a massive leap forward. A coding agent isn't just a glorified autocomplete that suggests a single line of code. It acts as a totally autonomous, tireless intern that handles the entire development loop. It writes the code, it tests it, and if it hits an error, it debugs it entirely on its own. It's a hyper-focused worker that literally never needs a coffee break.
And there you have it. We've mapped the whole AI lifecycle, from understanding basic tokens and dodging hallucinations to the nuances of fine-tuning, all the way up to letting autonomous coding agents loose. You're not in the dark anymore. You've got the vocabulary and the conceptual framework to actually navigate this incredible tech shift. So having unlocked all this, I'm going to leave you with one final question to think about. How are you going to use this knowledge to unlock the true power of AI? What are you going to build with your new tireless intern today? Thanks for hanging out with me on this explainer, and happy building.